In the last lecture, we so in the last lecture we started something called angle of repose. So we'll continue with the same. Under this topic, we came to know that this is the angle
Yes,
at
sir.
which the motion is. So at this angle, motion will not start, but it is about to start. So we take this as a limiting case, and just before this angle, everything is at rest, and just after this angle, everything is in motion. So mostly the question that they will ask you is like find the minimum angle at which the slipping begins or something and else. So the answer that we got is that theta r, the repose angle is always defined by the coefficient of static friction. Now, because it is repose, so it has to do with the static coefficient. So if a plane, let's say, let alpha be the angle of inclination of an inclined plane, then if if alpha is less than theta repose, what will happen? The object will remain at rest. Object will remain at rest. So it will never move. Okay. If alpha exceeds the repose angle, if alpha is more than angle of repose, what will happen? The object will accelerate downward. If alpha is equals to angle of repose, what will happen? So
Sir,
we'll
the
also
motion will
take that
just
as rest.
begin.
Yeah, no, not begin. We'll keep it at rest only. So this is two up to equals angles. Up to angle of repose, everything will be at rest. Just beyond it, it will accelerate. So before we start calculating the acceleration of an object down the plane, we need to first make sure that are they going to slip or not. And for that very purpose, this problem will help you in understanding the concept really well. So we have two blocks as you can see. And you can name it. Let's say NPS. And the coefficient of friction between the block and the plane is mu1. So theta is the angle given to for the plane. This is not the repose. This is just angle given. So what we do is we calculate the tan theta first, and then we check the mu1 and mu2 relation. So we take these three variables and we take the which one is bigger, which one is not bigger. Okay. So now we'll take the case one. So what if the mu1, mu2 both exceed tan theta? So if both the coefficient of friction is more than tan of theta, it means both the block will remain at rest. Why? Because the friction has won the match. You can think of that way. So the repose angle is tan inverse mu. So the theta is here less than tan inverse mu. You can see in that way. So this is the case one here. So now the question is, if mu1 and mu2 both are more than tan theta, we can say acceleration of 1 and 2 equals to 0. Because the repose has not been broken, so you have not exceeded the angle called angle of repose, so motion cannot begin. So the next question is, what is the reaction force or what is the friction force acting below the block M1 and 2? So what is F1 and F2? Tell me, what is F1 and F2?
Sir, zero only because of Newton's first law.
Okay. F1 is the what is F1? Friction force acting on block M1. So why it is 0? If it is 0, then why it will stop?
Sir, F1 is M1G sine theta.
M1. Very good. And what is F2?
M2G sine theta.
So obviously the weight component acting down the plane is balanced by the friction itself, and that is why it is not moving. So here the limiting question will never come. You are much into the range of static friction, and therefore you're not able to move. So what is the reaction force between 1 and 2? Reaction force between 1 and 2. Let's call it N1. What is the reaction force between 1 and 2 block? Are they pressing each other? Yes or no?
Yes, sir.
Are they? How can you say they are pressing? Tell me. If the friction acting below the block, I mean beneath the block, is balancing their weight component, then they have no tendency to move forward and hit the other. So if the individual block is balanced by their own weight, I mean their own friction, So if the weight component of each block is balanced by their own friction, then why they will press each other? Tell me. Why N12 will come into picture? So the answer this is zero, because the gravity is trying to pull each block and the friction is balancing each block independently. Now, because they are balanced by their own friction, then they will never press each other. For pressing condition, the M1 must tend to move forward first. So only when you overcome the friction, you can go and press. Understood? So unless the weight component of M1 is not exceeding the friction limiting value, it will never press the block in front of it. Understood?
Yes. So this N12 value is for that contact force between M1 and M2 block.
Yeah. So block the reaction between the block. We'll take the case 2. The case 2 says that tan theta, I can see this one, mu1 is less than tan theta, but mu2 is more than tan theta. Now this one is the most interesting case. So what will happen if the mu1 is less than tan theta and mu2 is more than tan theta? So let's first try to analyze the situation. Like what is going to happen first.
Sir, M2 will go down
So
and
yeah,
M1 will remain same place.
which block will try to,
So the
which
first
block
block
will
will try
tend to
to move
move?
down.
Yeah,
M1.
yes, correct. But M2 will try to be there, right? So M2 will try to be at the same place as it was, whereas M1 will tend to move down. So now there is a question like, is it necessary that the system must move? System is M1 and M2 together. So is it necessary that M1 and M2 will move? Or it is also possible that although M1 is having tendency to go down, but still the system may not move. So in such scenario, what do you do?
So the M2 uh, force will balance the piece of parameter.
So there will be a contact force, reaction force between them.
Yeah, that is 100% sure. So now the contact will be there 100% because one is trying to go down, other is trying to stop it. So the contact must develop. So there is no question about it. So now the question is, if M2 is not trying to go down, M1 is trying to go down, then what we need to check to make sure that they will go down or not. So how we can ascertain that the system will go down or will remain at rest? So for that very purpose, what we do is, if the block behind is trying to move and the front is stopping it, we take this as a cumulative object, like one system. And if you think this as a one system, then you can easily draw the net gravitational force acting down. So the net gravitational force will be how much? M1 plus M2 G sine theta. So this is the net gravitational force. What we do is we make another checkpoint called the total friction. total frictional force on system. So we can check that what is the net frictional force that is acting there. So total frictional force on the system means the total limiting friction. Limiting. So Fs max for the system is F1 S max plus F2 S max. We calculate this part separately. We check whether system as a whole is overcoming the net frictional forces or not. Because the question is whether the system will move or not. Because the first block is trying to move, but the second is not trying to move. So there is a tug of war between the limiting friction and the net gravitational pull, and if the winner will decide the motion. So it turns out to be this one is having formula mu1 m1 plus mu2 m2 into g cos theta. So now we need to take the again two cases, or you can say sub case. Case 2a. If Fs max system exceeds the or even equates the net gravitational pull. If this will happen, then again the acceleration will be zero. So nothing will move. So if the frictional force will take the dominance over the gravitational pull, the system cannot move. And in such scenario, what you will write is mu1 m1 plus mu2 m2 whole multiplied by g cos theta is more than equals to m1 plus m2 whole multiplied by g sin theta. And it turns out to be really a nice expression that tan theta is less than equals to, and this is like a weighted mean of coefficient of friction. So we preferably call this mu effective. Like if you have two block system and then if you want to find the equivalent frictional coefficient, so this is like a formula for that average, weighted average as we do. So mu1 m1 mu2 m2 upon m1 plus m2 is the weighted average, and that is if that is exceeding the tan theta, or you consider if the tan theta is less than this value, again the motion will not take place. Now this mu effective is a ready-made formula you can always use to determine whether the motion will take place or not, even without solving. So for two block problem, what we do is we check this value against the tan theta of the plane, and the winner will decide the motion will take place or not. So now, as we have already identified that the normal will develop between the block. So how much normal will develop? Can you tell me? This is a very straightforward answer.
M1 G sin theta.
Are you sure? See, which block is trying to move? One or two?
1.
And which block is not moving because of that? So one is
Second
trying to move, it means the gravitational force on the M1 block. You need to understand this first. One is trying to move, it means the gravitational pull on the M1 is exceeding the frictional forces. So limiting has been crossed. So the additional difference I need to supplied by the reaction force so as to balance it. So N12 is definitely the weight component of 1 minus the frictional component of 1. Understood? And the difference the N12 will provide. So M1 is trying to go down, it means the gravity is exceeding the frictional force. That's why it's trying to go down. So gravity is definitely more than the limiting friction. So by virtue of N12, it will experience a backward force which will try to overcome the net force. So N12 is this much. Is this clear to you guys?
Yes, sir.
So you need to be very logical. See, the friction chapter is almost like very organic in nature. You cannot have a formula to solve. So now N12 is M1 G sin theta minus mu1 cos theta. And this entire analysis which I'm doing is a big comprehension question of J advanced. So it has been I have been teaching this as a theory, and now the J asks exactly same question. You can go back and check J problem of advanced, and they ask questions like this one. So now we are done with the first part, the case A, the case 2A part. So the obvious choice for the case B part will be what? So case 2B part. And what is that? Okay, no, diagram is not important. So now if the gravitational force exceeds the net frictional force, I mean the sign. The other way of saying is if the tan theta exceeds the mu effective, so not, so if tan theta exceeds the mu effective, what will happen? So both will go down together or distinctly. Tell me, guys. If the gravity will exceed the net limiting friction, then system will move as a whole. And because the tendency was starting from M1 to move, so it will drag the block ahead because of its own exceeding weight. So in this case, the system A1 and A2, both the block will move together. So now the question is, what will be the acceleration? So you can solve for the system, and it comes out to a very nice answer. If you solve for the system as whole, you can say net gravitational force minus net frictional force by net mass. But even this lengthy expression is not correct directly. At if you rearrange, it will give you the G sin theta minus mu effective cos theta. So we'll get the direct answer for the acceleration of the block as a system. The mu is replaced by mu effective. So as long as they are moving together, for two block system, if they move together, the answer is always like this. In fact, if we have a 3, 4, 5, 6, 7, 20 block system, and if they are moving together, then the acceleration of the system is always this formula where mu effective is So in general, for any number of blocks, the mu effective write as summation of mu I mi upon summation of. So if we can make sure that all blocks are going together by making the contact together means they press each other. Okay. Then only you can apply this formula and get the answer. So we are done with the case 2. So we'll come to the easier cases now. So case 3 is definitely if mu2 is less than tan theta and mu1 is more than tan theta. So now which one will move and which one will not move? So since mu2 is ahead
Yeah.
and nothing is blocking the path of the mu2, so mu2 will just move. So acceleration of 1 will be 0 because it's not moving, and 2 will be just like a normal question, g minus mu2 cos. That's it. Because in this case only one block is moving. So now comes a slightly interesting case. If mu1 and mu2 both mu2 is less than tan theta, if both values are less than tan theta, then again both will tend to move. Now the question is, will they move together or will they move distinctly? And what will determine these two conditions? If mu1 and mu2 both values are less than tan theta, then should there be any like sub cases here? So let's say if mu1, I have to take the sub cases. Now imagine the guy which is behind is trying to accelerate faster than the block which is ahead, M2. Let's say M1 is trying to move faster than M2. Then the only way is both will drag together. Let's say M1 is Faraday and M2 is Nano. So of course, however hard you try, the Nano cannot exceed Faraday. So M1 is going to keep on pushing M2 forever, and they'll move together. Now for the accession of M1 to be bigger than M2, what is the condition? So if I say that uh, mu1 is less than mu2, what does it mean? So which block will have greater tendency to move? The block which is behind, and therefore they will move together or separately. The blocks will move together or separately. Tell me. Hello, 1 2 3 1 2 3. Am I audible, guys?
So blocks will move together.
Yes. So now the blocks will again move together. The question is, what will be their acceleration?
Correct. And 1 plus M2 times theta minus uh,
Because they will move together, so A on A2 will be equals to G sin theta minus mu effective cos. You can just do the way you did earlier. And the case for B part, if mu1 is more than mu2 and mu1 and mu2 both are less than tan theta. That is also here. That's why it's a sub case. So now both will move freely because mu2 will move faster than mu1, so they will separate. Okay. So acceleration of 2 will be more than acceleration of 1. So A2 will be this different value sine theta minus mu2 cos theta. A1 will be g sine theta minus mu1 cos theta. So what will be the A relative? What is A? Which one is bigger? So A2 minus A1 is how much? So if you subtract A2 minus A1, what will get is mu1 minus mu2 g cos theta. So this is the A relative. So what will be the relative separation as a function of time t? So A's relative will be half A relative into t square. So they may ask you to find the separation between the block after time t. So questions like this may be asked, or we have been doing. In fact, the last question, which we did, was something like that. So you can always calculate the relative separation between the blocks by using the relative formula. So this completes the discussion on the two block problem on the inclined plane. So we'll take some more examples. Okay. Pardon? Okay. So let's do some problem. Hmm. Okay, so now you can see there is a question in front of you. So I'll take multiple cases to solve this question one by one. Now the idea is very simple. I have to keep the smaller block at rest with respect to bigger block. Okay. I have to keep the smaller block at rest with respect to bigger block. Okay. So the question that we have to solve is find f to keep the mass m at rest now if there are multiple cases. So the first case is if, or you can say case one, mu s is more than 10 theta. The B case is mu s is less than 10. So think about it and then try to answer it. This is really challenging problem. It's not very easy to think, but if you can think, it's really good. Okay, tell me. You want to try or shall I solve? Tell me. Okay. So Abhay and Shish, are you guys trying? Abhay, are you getting the concepts? I think everyone's speaker is not working fine. You can write in chat in case if you're not able to speak or share what you want to say. So the part A is very interesting. I mean, that is so surprising that okay, we need to see this. It's really good. Okay, so before I solve this question, let me give you some prerequisites of thinking. So what you cannot think actually. So imagine we have a block on a rough inclined plane. So there is a block actually. And let's say the friction is sufficient to prevent the motion of the block, or you can say mu s is more than or equals to tan theta. So one thing is sure that the block will not move. So the first thing that we need to understand is how the forces will act. Now you may think in multiple ways, but one of the ways is very interesting. So there are only two forces acting. Now you may say, no, sir, there are three forces acting. I will tell you, no, there are only two forces acting. So what are the two forces acting here? Can you tell me?
Sir, sine, mg sine theta,
Pardon?
mg sine theta, and
So one force is acting gravity. See, I'm asking force, not the component. I'm asking simply force. So one force is acting is called gravity, and the other force is acting called
Frictional force.
surface contact force. Surface contact force. Now this is something interesting. Now we don't have the habit of thinking about the surface contact force. What we see is only friction and normal as the two distinct values of force. The fact is, normal and friction are born out of the surface, and therefore we can put together in a single force called surface contact force. So now the if one force is mg, if the block is not moving, the how the other force would act? That's the question. Think about it. If one force is mg, other force is the surface contact force, then how the surface should apply the force to keep the block at rest?
Sir, it will have two components, normal reaction and frictional force in the perpendicular and parallel direction to the. So it
Mhm.
will keep it.
But I'm asking what is the direction of surface contact force?
sir, it is slant towards the
Pardon?
bottom,
So it will be in inverse direction
the
to the
bottom
mg.
left corner, slant towards the
The
bottom.
only direction possible is opposite to mg, and the value is also exactly equals to mg. Now this R is nothing but the resultant of the frictional force and the normal reaction. So R is not coming from somewhere else. It is the exactly component of these two forces. You can think this way. So these two forces together is creating the Fs and N will always create a force which is exactly balancing the mg. Because if the three forces are in equilibrium, it means the resultant of any two force must be in the direction of third force. So what is what is the resultant of N and mg? It is opposite of Fs. What is the resultant of mg and Fs? It is exactly opposite of N. So what is the resultant of N and Fs? It is exactly opposite of mg. So the surface as a whole applies only one force, and that is exactly balancing the mg. Okay. Now this will answer the first question. Come back to the question here. So in the case A, if you look carefully, this is the case when block will not move, right? So block is not moving. What does it mean? So if the block is not moving, so in that case, the net surface force is acting this way. Now it is very difficult to realize that the force that we need to stop the system is zero because there is no horizontal force developing in the system. So if you think about the Newton third law, like this is R, this is mg. So the R is acting on the block upward. So as a Newton's third law, the R will act on the wedge downward. Understood? And that can be balanced by this normal. So as an action reaction pair, I mean, I should have written somewhere else, maybe on separate diagram. So what we need to realize is that this wedge so when something remains at rest is a very interesting case. If the friction is sufficient to hold the block at rest, it means it will be like glued to the object. So it will behave as one single object. So the reaction force, as we discussed, acting on the block is upward and the gravity is downward. Now I'm not drawing the normal and friction separately. I'm doing reaction force of surface as a whole. So now if you draw the FBD of the wedge separately, let's try to draw the FBD of wedge. So if we draw the FBD of wedge separately, the reaction force will act here like this. The gravity of its own value will be mg, and the normal will be like this. You can name it whatever you want to name. And therefore, the wedge is already in equilibrium because there is no horizontal force, and therefore the F required to keep the system at rest is 0. You need not to apply any force; it will remain at rest. Don't worry. So if the surface is very rough, in such case the external force is not required. So you can keep on putting things, and it will remain there only. So it will never create a tendency to move right or left. And that is not very intuitive. It's very counterintuitive to your brain, but this is the fact. Now the same question can be asked in this way. So this is the question, very famous question. So imagine there is a wedge of certain mass m. It is kept on a frictionless surface, and now there is a spring attached to it in a normal condition. So there is no compression in the spring. So try to understand. So now the compression in the spring is 0. Imagine if I bring a block and keep it here, and the friction coefficient is more than tan theta or theta. I have mentioned. Now, what will be the compression in the spring? What will be the compression in the spring after block M is kept on the inclined surface? So, what is what will happen? Yes, so the elongation will be 0, or sorry, compression will be 0. So you can say answer is the spring will remain in deformed state. In so these are the similar problems. So in the first case, I'm applying the force, and the other case, I'm saying no, I'm not applying the force. So how many of you are able to understand this question? Anyone
Sir,
finding
I
it very
understood.
difficult? Which part you didn't get? Tell me.
Yes, sir, I understood. You asked.
Abhay and Srishti, are you guys getting it? Atharv?
Yes.
So now can you do the B part for this question? Or maybe for this question also. So this is the case one. So my answer is as per the case one. I can create a question like for the same question, case two. What if and of course mu k is also given. Mu k is there. So mu s is less than tan theta. So find compression in spring at equilibrium of wedge. So assuming the wedge is at rest, not moving, what will be the compression in the spring? So actually, I do not write question properly. I normally formalize during the lecture only. That's what I do in general. I keep on creating questions as I when I required. So there is no formal description of question. You need to attend the lecture to understand what happened. So now the case two answer. What will be the answer here? So we'll come to the B part later on. Now, because the wedge is at rest and friction coefficient is not sufficient, as we discussed, mu s is less than tan theta. So the block is going to move down the plane, right? So the block is going to move down the plane. So block will have, because block is going down, it means block will go right and down. So if something is moving from here to here, the path is this way. So it is having some horizontal acceleration. Okay. It will have some horizontal acceleration. And the horizontal component of reaction force will do the same job. What does it mean? Now this is it getting too difficult? I don't have space. I think I need to go to the next page.
So that reaction force means that surface contact force.
Yeah, correct. So the surface contact force will act something like this. I mean, I can draw properly. So the surface contact will act not vertically up, rather tilted toward from the vertical like this, something like this, on the block. And this reaction force will have two components, one horizontal and one vertical like this. You can say Rx, you can say Ro. And then you will have gravity, mg. This is the APD of the block. And now, because we know what is that, we know that the block is having acceleration down the plane g sine theta minus mu k cos theta. So this acceleration is known to us, right? So we know that a block will move down the plane with this acceleration. So I'm not trying to write the what we say uh, friction and normal. No, that's like a lengthy process. So what I can see clearly that the component of acceleration in the horizontal direction will be how much? So what is the component of acceleration in the horizontal direction? It is a cos
Rx
theta.
cos
If I say
theta.
this as a, yeah, so I can say Rx equals to mass of the block into Ax. And what is Ax? It is m into a cos theta. And exactly the Rx will balance. Rx is balanced by the spring force, right? So if you come back to the wedge part, if you come back to the wedge part, now this is the biggest realization. Why the concept of R is important. If you solve by the very conventional method, it becomes too lengthy to proceed. Now I know that the Rx is acting on the wedge like this, and that needs to be balanced by the spring force. That's the only thing we need. So the spring force is kx, and now we know that the k into x equals to m into a into cos theta. So I am capable of finding the x at one go, which is a very lengthy process. If you don't do this way, it is really challenging problem. You need to write a lot of equation and then take the component of every force along horizontal and then solve. Now by eliminating the normal and friction together by R, things are really nice. Now this realization is a really big realization. If you can think this way, you are actually very deep into the concept of physics. So it's not easy job. It's really not easy. Understood.
Sir, I have
So
a doubt.
how many of you are able to answer? Yeah, tell me.
Sir, in that Rx and Kx one, why
Hmm.
means Rx is acting towards the wedge?
The Rx I'm drawing is for the block on the right side because the block is going down. So if this will go this way, it will have two component acceleration, horizontal and downward. So who will provide the horizontal acceleration? It is only
Right.
horizontal component of all force, right? So gravity cannot have horizontal component, isn't it? So the only possible way is that the reaction force must have the horizontal component. Understood? Yes or no? First of all, the wedge is at rest, block is sliding down because the friction is not sufficient. That is the case 2. So if the block is sliding down, then the direction of acceleration of the block can be resolved into two components, horizontal and vertically down, right? So horizontally right and vertically down. So it's like x I cap and minus j cap. So now the question is, which force can provide you the horizontal acceleration? So the answer is clear. The gravity cannot do the same thing because mg acts vertically down, so it will never provide the horizontal acceleration. So what we're left with? So we're left with the reaction force of surface. Now, how the reaction force of surface should act in order to facilitate the same? So the reaction force of a surface must act somewhat oblique to the vertical towards right. So that is what I have shown. And therefore, the R will have two components, Rx and Ry. Now, Rx, if you draw the ABD of the block only, if you draw the ABD of block only, the block, so it will have forces Rx, Mg, and Ry. See, the benefit of I'm getting here without drawing the normal and empty, friction, that I have less variable. So now I can see clearly all the forces. So Rx must be providing the x component of acceleration to the block, isn't it? So now because we know the actual acceleration of the block down the plane of any incline, this is this much. So the x component must be a cos theta, right? This is what I have written here. And once I get the Rx value through this expression, I can go back to wedge and draw the ABD of wedge. So the wedge will have many forces: Rx left, Ry down. What is its own weight, and the normal from here. So these all are forces acting on the wedge. Now the horizontal force on the wedge is only Rx and the spring force. And if you just equate these two, you'll get the answer.
Hello, sir.
Yes, understand.
Sir,
Yes, yes.
sir, I got disconnected for the
Tell me.
last 10 minutes. Sir, so what was the answer for the second case of the first answer? Previous question.
This question you're talking about?
Sir, no, that wedge one.
Which question?
What was the second case answer? Yes, that's
This one, the B part.
yes.
Okay, now the B part, yeah, the B part, yeah, the B part is still I have to, yeah. So now what is
So
the
no,
B
I
part?
got
Now
the
we can
answer.
tell me the answer.
Sir, I got F
Pardon?
force is equal to. Sir, I got the answer for the B part. I wanted to cross check the answer.
Okay, I think okay, I made a mistake here. So just I need to find F to keep the wedge at rest. Yes. In the first part, we got the zero. So this part gave you answer F equals to zero because there is no need to apply force to keep the wedge at rest because there is no force acting on the wedge in the horizontal direction. In the second case, what will be the answer? It is exactly same. Like the role of spring is replaced by the F, isn't it? Just try to realize. So if you realize here, so the exactly same scenario there, that this part is replaced by F, isn't it? And there is no difference. So what should be the value of F now for case 2? If someone has really understood this concept, you can tell. So the wedge is at rest, block is in motion. So how much force is acting on the, you need to apply to keep the wedge at rest?
Rx,
Exactly Rx. And Rx is what? Rx we have got.
Ma cos theta.
Correct. And A we know already because the wedge is at rest, so we know what is the acceleration of the block with respect to wedge. And that's also ground from answer because the wedge is. Is this clear? So the
Yeah.
answer is again the same. The answer is not different. Although I'm solving the spring problem, but the F part we can here see that clearly that this case 1 when mu exceeds the tan theta, here the F is not required at all because all forces are here acting like this. Okay. Now if I just remove this part, maybe I can. Okay, so now imagine if the on the wedge on the block, if mu s is less than tan theta, then the net reaction force on the block will not act this way, it will act somewhere this. And therefore you need to apply some force to balance the horizontal component of the reaction. So now R will act like this and gravity will act like this. Now what I am drawing is only R and gravity. I'm not drawing F and Fs and or Fk and normal. So that is not what I need actually. So I can just draw the value which I have drawn R, and then R will have two component on the block, Rx and R. And it is the Rx component on the wedge, because I haven't drawn the FBD of wedge separately, but it is the Rx on the wedge that will be balanced by F. So the F is balancing Rx, and the Rx we can calculate from the block concept, because we know the block is going down with axis on A, and Rx will become ma cos theta. That's simple. And A we know anyway. So what is A here, by the way? So it's very famous answer, G sin theta minus mu k cos theta. So now this is one really big challenging problem to attempt. So if you have any doubt, you can ask, because I think it's not very intuitive at first go to realize what I'm doing. I can understand it's difficult. So
So
anyone
can
having
I
any
say,
question?
explain the case 2 part again? Because sir, I got disconnected at that time. So.
Let me take an. Actually, I was trying to put everything on the same page so that you can see at once. So anyway, let me do it here actually. So you draw a wedge. You just simply draw a wedge. So let me solve by your way of thinking.
So the second question, sir, I was telling the spring
Which
problem.
the spring problem is exactly same problem. Like instead of uh, applied force, the question is to find the expression in the spring. Sorry, expression. I can say. Compression in the
So we
spring.
have to just replace the force by kx, and then x is equal
Correct,
to
correct.
that constant.
Yes, yes, correct. So that is the only difference. So now, if we have a this wedge and if we have a block, you can just draw the ABD of two things separately, and you just draw it the way you do. Like what I'll do is just separate the objects, like so that let's do the block part separately, not to be confused with the other part. So now, if you go by the conventional way of drawing, like, uh, normal, okay, and the component of gravity, like this is what you think, mg sin theta, okay, and the friction force, okay. Now, if it is at equilibrium, then this friction will be equal to how much? Mg sin theta exactly, isn't it? And this is how much? Mg cos theta. So what is the reaction force on the block, like this block? So one is M, one is F. So the resultant of this will be what? So numerically we know the value. So the resultant of these two may be something like this. I don't know. I said like this or like this. I don't know. Let's say I don't know how it is. So let me take the resultant something like this. And now I'll prove that this angle is also theta. How? So let's call it alpha. So what is tan alpha? It is Fs upon n. Can you see that in this triangle? So can I write tan alpha equals to Fs upon n? Tell me guys, yes or no?
Yes, sir.
And
Yes.
Fs is mg sine theta and n is mg cos theta. Mg will cancel out, so alpha is how much? Theta. Because tan alpha is tan theta, so alpha is theta. And that is what I'm trying to prove, that my reaction force will be exactly vertical. So now I have proved alpha is theta. So this is theta, this is 90 theta. So this is again theta. So therefore, if you make it theta, it is only possible when it is vertical. So now, if I draw exactly vertical line, you can clearly see if this is 90 minus theta, this is theta. So this only possibly can become theta. So what I have proved is that N and Fs together will create only one force which is acting vertically up. And the reason is the mg cos and mg sin having the resultant exactly like this. This is mg. So these two forces, what you normally draw, can be replaced by one force called the surface contact force. This is the surface contact force. Now, of course, we do not have the habit of thinking about the R. We always think N and Fs, and we believe that these are two forces. But what I'm saying is no, we have only like one force. These two will make it to one force called R. And gravity is the another force. So one is the force due to surface. And if you remember the very beginning lectures in which I explained that the origin of normal and friction are same. So they develop from the interaction of atoms at a very small scale. Anyway, so the idea is the R which I am drawing is something like this. Now imagine, try to imagine. Imagine if friction is not sufficient. What does it mean? The mg sanita is dominating compared to Fs limiting value. Then only it can move down, isn't it? Try to understand this part. This part is even more important. So imagine now that I'm saying that no, the block is going down. What does it mean? Which force is dominating?
MG
Is
sin
it
theta.
mg sanita? So mg sanita is bigger force, Fs is small force. Okay, but the normal will remain the same. It will remain mg cos theta only, right? On the block. Can we see this? Like n is still the value same, but now we know that this force has a decrease from Fs to Fk. Why? Because now the block is going down. Now, if one force will decrease, if Fs or Fk will decrease, what do you expect? How the reaction force of these two will be? So, how the component will shift towards the right, towards left?
So towards the right.
Exactly. So, vertical from vertical, it will shift somewhere towards the right of vertical because the F has decreased the value, N is still the intact. So, the force will shift towards the bigger value, isn't it? So, if you decrease one force, the resultant will shift towards the right. And now this is what I have done in the previous question, that I have told you that okay, in case of acceleration, the R will act at some angle to the vertical. Now, do you realize?
Yes, sir.
What I'll do is I just do a circle as a block, And what you need to realize that in case of motion, the reaction will act like this, and gravity will act like this. That's only two forces, the R and mg. That's only two forces. I need not to write all other forces, and that is why I can resolve the forces into two components, Rx and. So we know that the block is going down with some acceleration a, which is known to us in advance. So now I can write as Rx equals to max and mg minus ry, because mg is dominating, of course, is equals to may. Like I'm taking the value ay downward. Okay, and now to keep the wedge at rest, I need to do the FBD of the wedge. So if you do the FBD of wedge, how it look like? If you do the FBD of wedge, it look like something this. Rx, the reaction force will act like this. The Ry will act downward, something like this. And other forces, if you draw for the wedge itself, it's the gravity of wedge. So to keep the wedge at rest, the only force we need to apply is F
Rx.
horizontal, correct. And the numerically it is going to be equal to Rx. And Rx we can calculate actually from here. I hope everything is now making sense to you guys. If not, then you can
Yes.
practice a bit on your own, because probably this is what I can do for you guys. So rest you need to do practice and try to realize this entire question. This is definitely not an easy question. I take this question when I feel that okay, some of you can understand. Okay, so now I'll move to the next question. So we have done this problem like in the laws of motion chapter. So what was the problem in the laws of motion chapter? Let me remind you. So I'm taking the case 2 directly because case 1 we have discussed. So frictionless, and I'm taking that mu is less than 10 for sure. Okay. Now the question is find the F minimum to F maximum. So what is the minimum value of F and what is the maximum of F? So I want the find the range of F such that block M remains at rest. So find range F such that the block M remains at rest with respect to wedge. Now this was the actual question. I wrote earlier. So now here the wedge is not supposed to be at rest, or not necessarily be rest. So now we have to find the what is the minimum and what is the maximum force that I can apply. Is still the block will remain at rest with respect to wedge. So now in the normal case, when if you do not apply force, everything will move because the friction is not sufficient to keep the block at rest. So you can start with the minimum force. So if you want to try this question, you can try. I can give you maybe
Sir, yeah.
5-6 minutes. Else I can solve directly. What do you want? Do you want to try? Anyone?
Sir, try.
Yes, fine.
Okay, go ahead.
Sir, I'm getting F equals to mu mg. Sir, you're muted.
Oh, I'm sorry. I was thinking about that. Okay, once again. The first thing is the gravity, the block will have the tendency to move down the plane with respect to wedge. In that case, the friction will have tendency to act up the plane. Okay. And now, because mg sin theta is bigger than mu n, so it will try to go up the plane, down the plane. So we need to accelerate a bit the system as a whole, so that a pseudo force will develop on the block like something ma, and this pseudo force will also create a component this way, and this
Yeah,
component
got
along
that.
with mu n will balance the mg. Yes, tell me what you got.
So I got for the maximum value of F.
Okay,
So it's
so let's see.
capital MG sine.
So we are saying f minimum or f maximum.
So maximum F max.
Yeah, how much?
So capital MG sine theta minus mu capital MG cos theta. So capital plus plus small mg cos square theta.
Like this.
Yes.
Okay, so we'll come to that. So now the first step is you need to assume, let's say the acceleration of the wedge is a, and that will create a pseudo force backward. Okay, and because this is angle theta, so this is also theta. Now in the frame of this is the pseudo force. This is the pseudo. So because the block is at rest in the frame of wedge, so we are going to solve the question in the wedge frame itself, and it is non-inertial frame. So the pseudo force must be applied. So for equilibrium of block in the wedge frame, what we can write? So we can write mg sin theta is equals to ma cos theta plus mu n. And what is n here? N is mg cos theta plus ma sin theta. So first we need to calculate the acceleration part, and then we are good to go. So this is what you see earlier. If you remember, we should only balance the mg sin theta with ma cos theta, and we used to get a equals to g tan theta. Now, because of the friction, a part is already balanced, and then the ma should only balance the remaining part. But in the due process, then n has also changed. So we have to be very careful. We cannot write mu mg cos theta. Normally, friction force you write, but it is a good habit to write mu n as friction, and then substitute n as per the question. So now we have two equations, and now we can solve. And this is what I'm solving for the f minimum case, not for maximum. I'm solving for minimum case. So what I'm going to get is mg, and this is definitely wrong. So I'll come to that. Mg sin theta equals to ma cos theta plus mu into just mute. Abhay, mute yourself.
So you're muted.
Okay, I'm also muted. Sorry. So now we have mg. The first expression is this here. The n is the here, and what I'm saying is always have a habit of writing friction as mu into n. Don't write mu mg cos or sin whenever you solve question. because you never know that n can change in different situations. So it is a good practice to keep the n as a way of writing friction force mu n, and then derive the n from the FBD and then substitute it. So in the minimum case, the block will have tendency to go down and therefore friction will act up. So a part of gravity is already balanced by the friction force. So ma cos theta will balance the remaining part. So that is what we have it in the first equation. And the second is the normal value. And now we are just substituting the normal from the equation 2 in the equation 1. So what we are getting is m will cancel out throughout. M is common. So g sine theta minus mu cos. And if you look at the a part, it is a cos theta plus mu sin theta. So the acceleration that we are getting for the system is very straightforward. And now this is meaningful. Now you can clearly see that if I put mu equals to 0, I'm exactly getting the answer that we had in the laws of motion, g tan theta, that you can do. And now because the system as a whole is moving together, so I can write f equals to m plus m into a. That's m. You just need to multiply m plus m because as a whole we are moving together. So f is moving both systems together, so the f minimum is m plus m into a. That's why I said this is wrong and definitely wrong. Now, if you do the f max, the only sign will invert. So your answer is going to be okay. For f max, the answer is going to be okay. In fact, so for f max, so for f max, the acceleration will just change the sign plus so what is the meaning of f max? So in the case of f max scenario, the acceleration is too high that the block will reverse the tendency of motion. So whenever you go to f max, the tendency is reversed. So block will tend to go up. So now because the tendency is this way, so now the friction will act mg sine theta will act for sure. But at the same time, the friction will also start acting downward because your tendency is to upper, and this will become mu into n. And it is a pseudo force which will alone balance it because that's anyway very high. So the pseudo force component, because that is cos down, the normal, and so the equation for normal remains the same, which is m that it is balancing every other force. So now ma cos theta is equals to mg sin theta. This is for f max. Mg sin theta plus mu n. And just if you rearrange mu into ma cos theta. You can take a common and you can see cos theta minus mu sin theta, and you can say g common, so sin theta plus mu cos theta. So the only difference is the change of sign. Now these kind of questions is very common. Like in competition, they are very much happy to ask questions like this: minimum, maximum. So this is the maximum possible acceleration. In fact, you can say this is the maximum possible acceleration for which the block will remain at rest with respect to wedge. Okay. And therefore the F max will be equals to the total mass of system, because system will always move together into it. If you want to write F max, you can write M. And therefore the F will be anywhere between F mean to F max. That is the range of force for which the block will remain safe. So mathematically, we only analyze the extreme cases, and then we know that it is, so any force which you apply between these range will keep the block at rest. Understood? So in the MCQ, let's say F max turns out to be 120 Newton, F min turns out to be 70 Newton, and then they will ask you for which force the, let's say if F min is 70, if you calculate and get the answer, F max is 120, and the option is like this: 60, 80, 100, 120. So which of the following forces force of forces can keep the block at rest? So which of the options or option are correct? Is or are correct? Tell me, guys. So which force can keep the block at rest?
Um,
So
Sir, no,
anything,
80, 100, 120.
all three. So any force which is in the range of minimum or maximum will keep the block at rest with respect to wedge, as we discussed. All
Sir, I want to see the previous page. Yeah, sir, done.
okay. So what is the other method of thinking? Like, can we solve this other method? Like, this is a very lengthy process. So can we solve this maybe using a simpler process? Is it possible? It turns out to be we should. This is what I'm expecting. Let's see if it works. So, like instead of a block, I'm just putting a circle. That's easy for me in order to draw this in Y. Okay, this is point object, not a circle. It's a point object. And now, so if you remember, we had realized that if the system will accelerate right, then the reaction force, and if it is not going down, if it is standing there only, so I can say something very similar. Rx, R. This is the Rx RY. Okay. So now the if the tendency is to go down, it means the gravity is dominating over the frictional force, the component wise, and therefore the Ry will act somewhere towards the right, and that we have discussed. And now it is moving with the same acceleration as that of the end. Now we also know that the friction is limiting value. So if friction is limiting, Ry is balancing the direct. So if the friction is limiting, then we know something. What we know? Do you remember something? If friction is limiting? You probably have forgotten this part. Okay, so let me go back to the very preamble diagram. Let me draw the vertical line out. Now we know the normal act like this way, okay, and friction will act either this way or this way depending on the tendency. So I'm taking the minimum case. For a minimum case, how the friction will act up the plane, right? Correct. Again, I'm taking to different thinking part. Okay. So if this is limiting friction, because the friction is acting maximum, so this is the mu n acting and this is the n acting. So this angle we can calculate, isn't it? I think we have done this part. What is this angle?
Theta.
Look, tan alpha is how much, guys? Going wrong. So tan alpha turns out to be mu only, if you remember. In this channel,
Yes.
this is mu n. And that is what I'm trying to emphasize, that we need not to write everything in the world. And now my job is extremely simplified. And this angle is theta. This angle is 90 minus theta. On that. So what is the vertical component of R? What is the vertical component of R? Or what is the horizontal component of R? So the vertical component of R is, or you can say Ry will be how much? R sine alpha plus 90 minus theta. I think this is the right answer. Yes. And what is Rx? R cos alpha plus 90 minus theta. I hope this is not very difficult. Okay. And we also know that Rx is equals to M into A, and we also know Ry equals to Mg. Okay. Yes or no? Do you realize this fact? For the blow, I mean, I'm not solving. In fact, I'm not solving the wedge frame. I'm just writing in the ground frame, everything, and I'm writing for the A minimum case because I know only in A minimum case the friction will have tendency to go up. If you have realized this, let me know. Else, I'll stick to this for some time, and maybe this will help you in solving the question very efficiently and very fast in friction chapter. So, how many of you are able to understand this? This is Rx, and the R we can resolve two components. This is the normal resolution of vectors. Come on, this is not difficult. And gravity is acting
Sir,
now.
understood.
And because the wedge and the object is accelerating together, so I can say the ball is also, the block is also accelerating towards right with the same acceleration as the wedge, because that is the condition. We are assuming that the block is not moving with respect to wedge, so they must have same acceleration. That is the idea, right? So now what we can see that Ry is mg obviously because it's balanced. Vertically it's not moving, and horizontally they have same acceleration. So I can say r cos whatever is m. And now I'm done because I got the acceleration in one line. So what is a by g? Just divide the equation. So 2 divided by 1, and I'm got the answer. So a by g is how much? It is cot alpha minus theta. I think that's fine. Sorry, tan. It becomes tan because 90 or anyway, it is cot 90 plus alpha minus theta. That's okay. But cot 90 plus theta is what? I think in the third quadrant, tan and cot are positive, right? Yes, no, no, yes.
Yes, sir, positive.
Can we write this as tan alpha minus theta? Can we write yes or no? Yes or no?
Yes.
Come on. So I got the answer G tan, and that's my answer. So F minimum is how much? I got the answer in one line. F minimum is M plus M into 8. That's it. I got the answer. So now you may be wondering that, but this is not matching. So come on, this is not matching the answer that we got. No, it's matching actually. You need to just realize this part in detail. So this is tan A minus B from a tan A minus tan B upon 1 plus tan A tan B. No, so it is still not matching. No, it's matching. You need to see this again. Because tan alpha is mu, so mu minus tan theta 1 plus mu tan theta. No, so it is not matching. No, you just need to add sin and cos. You get mu cos theta minus, somewhat we have made a mistake. Is it theta minus alpha? 90. I think we have made a mistake here. The cot 90 plus theta is what? Negative. It's minus actually. So I can write this as minus this, or we need to make it a small change. Theta. Let me just remove this part. And then you can keep on writing. So we got A equals to G tan theta minus alpha. And now we have the answer. So F minimum is how much? Capital M plus small m into, or in fact, I can just write the A part in detail. If you expand it, what you get? You get what you're looking for. So this is tan A, tan B, 1 plus tan A, tan B, and it turns out to be exactly the same answer. So you can add sin and cos, and this is mu, this is sin theta by cos theta into mu, and if you just rearrange, then a bit messy, but this is sin theta minus mu cos theta upon cos theta plus mu. You can realize that we can do something in one line. I mean, this is so powerful. If you can really realize this part, we are done with the very tough, challenging problem in one line. So this is essentially one line problem. So anyone who is able to understand this, I mean, this is really difficult. I understand. Are you guys clear with this concept?
Yes, sir.
So you need to do a lot of practice. Like the R concept, the removing the normal and friction, and bringing R into picture is something which you need to develop, in thinking. So this is not very easy. The other case will be, the only difference is the alpha will be on the below side, right? So instead of on the above the, like on the left of normal, it will be towards the right of normal. So I'll just do the diagram and I'll not solve. I'm giving this to you as a homework. You can practice a bit. Anyway, this will do. Now this is a normal. So for A max, the n is like this, but the mu n will be somewhere here. This is the mu n part. And now because this is the mu n part, so this is the R part. This is R. And now this angle is alpha. And whether tan alpha is as usual mu. So now we got the tan alpha part. And now we know that the other angles are pretty much known to us. So this angle is theta. So this is how much? 90 minus theta, right? Sorry. What am I doing? My bad. This is entire is 19 theta. This is correct. So what is this angle? Now this is what is interesting we're looking for. So what is this angle? This is 90 minus theta minus alpha. So this is 90 minus theta plus alpha will come into picture. That's it. The only difference is this much. And this is what we're looking for. Then rest is simple. So Rx will be MAX, Ry will be MAY. That's it. Sorry, what am I writing? Ry is MG, and the Rx we can write as R cos 90 minus theta plus alpha, and this is R sine. And rest if you divide MAX is MA only. So the AX by G, which is that's only, or A by G, let's remove this. Just to keep the consistency with what we wrote previously. So now we can write something here. So A by G turns out to be how much? It's cos 90 minus theta, which is sin theta. So I can just write this becomes in fact tan theta plus alpha. That's only difference. So the A becomes G tan theta plus alpha. That's the only difference, and then we know the answer is if max is capital M plus small m into G tan. So now the expansion will give you the desired answer. Anyway, so we are done with this problem. Okay. Okay, so we are done with a lot variety of questions. Now we have to go to some simpler problem, maybe not simple enough, but so next is okay, basic problems. So we have a chain which is suspended from the table. So 1/4 is hanging here and 3/4 is here. So if the L by 4 is the maximum length that can be suspended at equilibrium, then find the value of mu. If L by 4 is the maximum length of chain that can be suspended at equilibrium, then find mu. So this is a pretty easy question. You can do it quickly. So can you tell me the answer? This is not difficult. Okay, so tell me the answer. I think this is not difficult. This is pretty
Is
straightforward.
it in Mumbai?
Pardon?
Sir, is it 1/3?
Yeah, correct. That's the right answer. 1/3 is the right answer. Okay, so the friction force will act only on the part of the chain which is on the table. So the normal will be developed as per the weight of the chain on the table part. So not on the
त्याच्याने
hanging
एक
part.
हात मारले तो विधान आहे पहिला तयार कळलं
So
ना
mute yourself. Whoever is there, mute yourself. So now we can see the pull part. The pull force is gravitational pull. So this part is kind of pulled by the gravity, and this part is pulled by the friction. The friction here acting is the entire part friction like this way. So this is the friction. To find the mu minimum, I mean, so what the minimum force? Not mu, just little maximum length. Yeah. So this F must be Fs max because we are taking the maximum friction to balance it. So now this is the hanging mass. So we can let lambda is the vector we are writing. So lambda L by 4 into G, and the Fs max will be mu into N, and the N will be how much? It's mg, which is lambda 3L by
Lambda 3/4.
so now it's very easy. So now mu into lambda 3L by 4 into G equals to weight of the pull, which is lambda L by 4 into G, and then it's will be that's the only easy problem. Okay. So you may get a question like this. The chain can create something nice problem, something like this. In a box. So the next problem is slightly challenging. Like, okay, so this is So let's say if I give you a question something like this, if I say we have a chain suspend something like this. All right. So now we have a chain something like this. And if I say this is L1 part is here, the L2 is here. The total length is and coefficient of friction is mu. If I give mu equals to maybe 0.6, it's a very big mu. So find maximum ratio such that the chain remains at. Okay, so this is the question. This is really challenging question. So mu is really big value. So when mu is really big value, you need to. Uh, it's up to you think about it. So if you want to try, you can try. Then else also. Yes, tell me.
3/4. No, sir.
Yeah, tell me.
3 divided by 5 ratio 3/.
So now, if you look at the first of all, you need to check something. So if you check tan 60 is root 3, which is definitely much more than mu. So the left incline will always facilitate the motion of the object. It cannot stop it at all because mu is less than 0.3. But the right is 1 by root 3. So 1 by root 3 is, if you calculate, these are the values which is very new. It's 0.577, which is less than 0.6. So every part of the chain on the right will always be at rest because the friction is always sufficient. So you can actually increase the L1 and that will increase the. So the only tendency you can develop is for the chain is to move like down on the left and up on the right. And the moment this tendency will develop, friction will start acting on the down the plane on the right, okay, and up the plane on the left. So the net pull force, we have to actually balance the net pull force by the net frictional forces. So I think this is not difficult. So the pull force here will act this way. The pull force here, this is the gravitational pull. So the G will act this way for the part. Okay. And the friction will also act here. So here the friction will act like this one. Because you're trying to move down on the left side. Because L1 will increase as L1 will keep on increasing, it will try to pull down. And therefore, okay. So now the G will act down, gravity is trying to pull down. And now the frictional force on the right chain will be also down. But on the frictional force on the left chain will be up. Why? Because the tendency we are trying is this way. We want this tendency. The tendency is down. Now, once you understand the tendency, because I am trying to maximize this ratio, which means I'm trying to maximize L1. So the definitely the tendency is going to be left on. So once you understand the tendency, it is only about writing the value. Okay. So let's write all the pull force and all the frictional force, and because it is at rest, so they are balanced. So it turns out the pull force is lambda L1 G sine 60 minus. So let me see the supporting. The L1 will support downward, and everything else is right. So the pull force is only this way. The lambda L1 G sine 60. All is preventing the motion. So it's like lambda L1, or you can say mu. So frictional force will be mu lambda L1 mu m cos theta G cos theta. Hello Jash. Hello Jash. Hello, hello, hello.
Hello.
Come after 15 minutes.
Okay.
So now this is mu lambda L1 G cos 60. And so now the other force is the friction force of this part. The other part is lambda L2 G sine 30 and lambda mu lambda L2 G cos 30. And this is the entire breakup. So now you can take the lambda and G will cancel out from both sides, and what you need to do is just take the L1 together and L2 together. L1 together will be how much? Sine 60 minus mu cos 60, and this is easy, and this will be L2 into sine 30 plus mu cos 30. So now you got the ratio. Whatever is the answer is the answer. That's not very difficult. Okay. So we'll do, I mean, of course, there are other varieties of questions which are left, which are even more challenging than what we have done today. That will take care in the next lecture. So what I'll do is I'll share the some question sheets. You can start doing the problem as anybody are doing from SC Verma. So I hope SC Verma is over for all of you, or is it still going on?
So still going on.
So are you finding any difficulty in solving SC Verma questions?
So few questions are difficult. Only.
A few questions. So you can, I mean, of course, you can discuss in tutorial. In case if you still find difficult, then only you can discuss here. So I hope that the tutorial will be sufficient. But in case if something happens, you can ask me. All right, guys. So we'll see in the next one.
Thank you, sir.
Bye and take care.
Thank you so much.